Okay, so let's talk about today's daily Leetcode problem. Subarray sums divisible by k. So you have been given an integer array nums and an integer k and return the non-empty subarray such that the sum divisible by k. Uh, that's all about the question. You have to see the subarray having a sum not equal to k but divisible by k. So there are many possibilities for that, and then there comes the thing that you can check for every subarray, right? And then see what is the sum of the subarray, but that's take n square time. That's not gonna happen, right? So you have to efficiently find a way that you can check all the subarrays in n or n log n time, and the subarray and their sum that should be divisible by k. So the logic for this is pretty standard and straightforward, and we have to cover this in one of the videos before, because we have covered this in one of the uh, we have covered this question as well in previous video. So let's just discuss it again simply. So when you have to find a subarray having a sum divisible by k, you check this nums array, and then you create your map. You create your mapping of mod k. Mod k means what is the remainder of k, sum mod k, right? So you make your running sum and running sum mod k. So for example, when mod k repeats in this running sum, it means then sum between the two indexes is a multiple of k. So for example, 4 is repeating, it means the sum between these two is 5, which is divisible by. So 4 is repeating, sum between this is 0, 0 is also divisible by 5. And sum again repeats, it means which sum, this sum is divisible by 5, like minus 5, yeah. And that's about it. So complete sum is also divisible by 5, that's why 0 is repeating, okay. So this is the logic about this problem. Let me show you how it is equal, because now let me write the running sum. Running sum up till this point is 4. Okay. So I will mark that, my difference, my mod k is equal to 4 at this point. And okay, so running sum up till this point is 4 plus 5 is 9, right? But I will store it as the 9 modulus 5, which is 4. Now modulus repeats because modulus k was here 4, again it is 4, which means 9 minus 4 is equal to, perfectly is equal to 5k, right? Which obviously is. So that's why we can say we got a subarray sum having multiple of k, right? That's why we'll just add it by 1. So let's say we added by 1 answer. Answer mein we add something by 1, and now again we'll see running sum is 9. The difference between these two sums is 0, right? Which means this is also, this subarray is also divisible by k. How we will see that? We will see that the running the modulus of running sum 4. 4 again repeats itself, because 9 modulus 4 is 4, 9 modulus 4 is 4. When it is repeating, it means either this is 0, or this is 5, or this is 10, because in all the cases it will repeat, right? In any other case it will not repeat, because whether it's 4 minus 10, it's 19. 19 also has 5, mod 5 equal to 4, but currently it was just 0, so that's why it's just not changed. So now what will we add? We will add the frequency of 4. How many times the 4 has repeated? 1 and a 2. Because this frequency representing what? This frequency representing different subarrays. One subarray is just this 0, and the other subarray is this 50. Okay, so that's why we will check the number of uh, 4 which you have occurred before. Now we will move to minus 2. It will become 7. Mod will become 2, which has not occurred before. So this is something new for us. And then go to minus 3, it will become something like 4. Mod 4 already occurred previously 3 times, right? So I will add plus 3 for that. Why plus 3 for that? 1 is basically this minus 5, then a subarray like this 3 length subarray, this is also minus 5, then this 4 length subarray having sum equal to 0, right? Anything else? No. So these three subarrays which we got, we can just say like what is the modulus for how many times it has occurred before, and every basically yeah, every subarray between these are a good subarray divided by 5, so that's why 3. Now 5 over 1 plus 1 is 5. As we know, this 5 is basically, the sum of complete subarray, which is obviously good for us because it's a divisible by 5. So we have to add plus 1, but we will say, okay, the map where there is a modulus 5 is equal to 0 because 5 mod 5 0. How many time it has occurred before? So initialize with map with 0. We say that, okay, 0 is the current sum and 0 is also divisible by 5. So that, whenever the 0 occurs again, so we can just say plus 1. So total is basically add all these up. 1 plus 2 plus 3 plus 1 is 7. That is the whole approach behind this problem. Let's just code it up quickly. It's nothing do. I've just solved this problem recently. So yeah, also I covered this on my channel. So do check it out. And I also covered its one variation. If you want more idea about this, then you can check this out. And I is equal to 0, I is less than not 0. I can just go auto I in nums. I will add my some running sum basically. Uh, I modulus k sum modulus equal to k just to be sure that I'm getting a remainder. But if it becomes negative, okay, I don't want negative reminders. S is equal to k plus s, something like that, and then we count plus equal to m of s, how many times it has occurred before, and you can do mod k over here. Otherwise, you can just leave it like that, I think. And m of s plus plus. That's fine, I think. Acha. Map of 0 is 1. You're gonna return count. Try to sum this up. Yeah, pretty good efficiency. Okay, guys, that's about it. Anything else? No. So this is the whole logic for this problem. You have to maintain running sum, you have to maintain the remainder, and check when the remainder repeats. This means the subarray has sum which is divisible by k. That's why you have to plus 1 for that. Not plus 1 basically, yeah, plus m of s basically how many times it has occurred before. Okay, there is also one variation which I also covered in the some of the previous video. Let's see if this is that's there or not. Subarray make some divisible by p. Yeah, that is also the variation I have covered. Subarray sum equals k, the very simple thing. Count number of bad pair, I think also I covered. It is easy problem. Take a count number of bad pairs is easy problem. But this make some divisible by p. This is a good variation which you can solve after solving this question. Um, yeah, so in this, what you have to do, you have to make a subarray sum equal to p, length of the smallest subarray, need to remove such that the remaining array becomes equal to, divisible by p. So just try this question. If you get this, it's good. If you don't get this, then I have covered this in my video, one of the videos. You can see that. Okay, guys, bye.